Algebra 2, Lesson 5-3, Solving Polynomial Equations. The essential understanding with this lesson is that if x minus a is a factor of a polynomial, then the polynomial has value 0 when x equals a. In other words, take x minus a, set it equal to 0, and solve it. If a is a real number, then the graph of the polynomial has a comma 0 as an x-intercept as well. To solve a polynomial equation by factoring, you have to do two things first. Write the equation in the form of p of x equals 0 for some polynomial function p. So if I have something that is not set equal to 0, I need to make sure I set it equal to 0. And then factor p of x, use the zero product property to find the roots. So let's take a look at these two questions down here. Okay. What are the real or imaginary solutions of each polynomial equation? The first one here is already set equal to 0 for us, and it's already factored pretty much, so all we have to do is solve it for x. In each case, I can solve each one for x. Remembering back to where when we first learned how to solve quadratic equations, we can solve them by taking the square roots. So I can have x squared equals 1 and x squared equals 4 to be negative 4 because I move and I add 1 and I subtract 4 because they're both set equal to 0. So now if I have x squared equals 1, x will equal the square root of plus or minus square root of 1, and x here will equal the plus or minus square root of negative 4. Okay, well, the square root of 1 is 1, so x can equal plus or minus 1, and the square root of negative 4 is 2i, so x can equal plus or minus 2i. So our solutions to this particular polynomial equation, our real number solutions are plus or minus 1, and our imaginary number solutions are plus or minus 2i. Sometimes you will only have real number solutions, sometimes you will only have imaginary number solutions, and sometimes, as in this case, you will have both real and imaginary number solutions. Number 2, x to the 5th plus 4x to the 3rd equals 5x to the 4th minus 2x to the 3rd. First of all, we have to set this equal to 0, so I'm going to subtract. I'm going to move the 5x to the 4th to this side. I'm going to move the negative 2x to the 3rd to this side as well. So I will add the 2x to the 3rd, and I will subtract the 5x to the 4th. So essentially, oops, x to the 4th plus 2x to the 3rd. These will cancel, and I will have x to the 5th minus 5x to the 4th, and 4x to the 3rd plus 2x to the 3rd is 6x to the 3rd, and this equals 0. The next thing I will do is take out the greatest common factor. Okay, my GCF here happens to be x to the 3rd. So if I take out an x to the 3rd, okay, I will have, if I take out x to the 3rd, I will have x squared minus 5x plus 6 equals 0. So I now know that x to the 3rd equals 0, and x squared minus 5x plus 6 equals 0. Okay, x squared minus 5x plus 6 will factor because I'm looking for a product of 6 and a sum of negative 5, which is negative 3 and negative 2. So I get that to factor to x minus 3 times x minus 2 equals 0. And over here I have x to the 3rd equals 0. If I take the cube root of this, the cube root of 0 is still 0. Here, if I solve each one of these for 0, x minus 3 equals 0, x minus 2 equals 0, x will equal 3 and 2. So our solutions to this particular quadratic equation, not quadratic, to this polynomial equation is 0, 3, and 2. And the order doesn't matter how you list them. You can list them smallest to largest if you'd like. Okay. Now, sometimes you can solve polynomial equations by factoring the polynomial and using the factor theorem. Okay, just like we just did with zero roots theorem. Recall that a quadratic expression that is the difference of squares has a special factoring pattern. Similarly, a cubic expression may be the sum of cubes or the difference of cubes. And up until this point, you've never learned how to factor the sum or the difference of cubes. And I will show you how to do that in a few minutes because there's a special formula for that, just like there is for perfect square trinomials and the difference of squares. Right. Now, here's a summary of some polynomial factoring techniques. The first thing you need to pay attention to is you need to factor out the greatest common factor. That's always what you look for first. Every single time you have a problem, see if there's a GCF. If there is, take it out. If we look at this problem, 12x to the 6th plus 8x to the 4th minus 48x to the 3rd, we should recognize right away that 12, 8, and 48 are all divisible by 4, and I can take an x to the third out of everything. So I'm going to take out a 4x to the third. And when I do that, I'll be left with 3x cubed plus 2x. And then 48 divided by 4 is 12. So you get 3x cubed plus 2x minus 12. Now, quadratic trinomials, remember these are where we're looking for the product and sum. Right? For in this particular case, I would look for a product of 30 and a sum of 11, which would be 6 and 5. So then I would do 2x squared plus 6x plus 5x plus 15, and then factor first two, last two. If I do that, I can take a 2x out of this. I'll be left with x plus 3. Over here, I can take out a 5x, and I'll be left with x plus 3. So 2x plus 5, not 5x, sorry. 2x plus 5 is one of the factors, and the other factor is x plus 3. Okay. In the perfect square trinomials, remember these two patterns are very nice to know. It's always a good idea to know these two patterns, this one here and this one here. Right? They give you the nice pattern. So what I'm doing here is I'm looking at this. If I have x squared minus something plus 49, how do I make that a perfect square? Remember, I take the square root of x. 1x squared is 1. The square root of 49 is 7, so it's going to be a 7 in the middle. There should be a 14 in the middle because you have to multiply by 2. So x squared minus 14x plus 49 will factor to x minus 7 on the squared. The difference in squares, a squared minus b squared equals to a plus b times a minus b. So if I have 16x squared minus 11, okay, if I look at that, the square root of 16 minus 4, the square root of 11 is just the square root of 11. So I'm going to end up with 4x plus the square root of 11, 4x minus the square root of 11. And that may look really weird because you might say, we never factored like that before, but you can do that when you're working with polynomials. Okay? And of course, we already know how to factor by grouping because we've done that just to factor our normal polynomials. So if I have x cubed minus 3x squared plus x minus 3, first thing I'm going to do is look at how to group it, and pretty much we group it first two, last two. Okay? And if I look at the first two, I can take out an x squared. And I get an x minus 3. On the second one, I can take out a 1. I get an x minus 3. So I get x squared plus 1. And I get x minus 3. Now, sum or difference of cubes. Here's where you need to know your formula, because you really can't factor it any other way. There's no product or sum to look at. You basically have to know the formula to factor the difference of a cube or the sum of a cube. Just pay attention to what you're looking at here. If I look at my sum of a cube, if I have a cubed plus b cubed, that will factor to a plus b times the factors a squared minus ab plus b squared. Notice if it's a sum, the first term is positive, the first factor is positive, and then you have the a squared minus ab plus b squared. There's only one subtraction sign in either one of these formulas. You just need to know where that subtraction sign is, because other than that, the formulas stay the same. Okay, so a cubed minus b cubed is a minus b, that's where the subtraction sign comes. Then it's a squared plus ab plus b squared. So if I take a 8x to the third plus 27, first thing I need to know is I need to know what is the cube root of 8x to the third. Well, that would be 2x, because 2x times 2x times 2x gives me 8x to the third. And what is the cube root of 27? Well, that's 3. So if I follow this formula, because it's a plus, I'm going to be using this formula right here. I would take and do a plus b, so in this case I'd be 2x plus 3. And then I will do a squared, which would be 2x quantity squared, minus a times b, which is 2x times 3, plus b squared, which is 3 squared. So I have 2x quantity squared. That's how they came up with 4x squared, because you have to do 2 squared x squared. which is 4x squared. Then we have 2x times 3, which is 6x. And then you have 3 squared, which is 9. So factoring by cubes is not hard. You just have to know how to plug it into the formula. All right, the sum of the difference of cubes is a new factoring technique. Here I wrote them out again so that you really understand that I'm very, very much wanting you to try to memorize these, because there's a good chance that they'll show up on the SAT exam, and I don't think they always give you all the formulas you need. They assume you know some of the formulas. Okay, now we're going to solve polynomial equations by factoring. And what are the real or imaginary solutions of these? X to the fourth plus 16, or x to the fourth equals 16, means if I solve this and set it equal to 0, I get x to the fourth minus 16 equals 0. Okay? That's the difference of squares. And I get the square root of x to the fourth, which is x squared, and I get the square root of 16, which is 4. Okay? So here, essentially, I will have x squared plus 4, x squared minus 4. Now this x squared plus 4 will factor again if I use the imaginary number system. Remember, okay, if the only way you can factor the sum of a perfect square, because 4 is a perfect square and x squared is a perfect square, is to use the I. So this would factor to x plus 2i, x minus 2i, and then x squared minus 4 will factor to x plus 2, x minus 2. So, if we're all going to set all those equal to 0, right, if we set x plus 2i, x minus 2i, x plus 2, x minus 2 equal to 0, x will equal plus or minus 2i and plus or minus 2. So it has 2 real number solutions and 2 imaginary number solutions. Okay, x to the third plus 125 equals 0. That is a perfect cube. Okay, you should be able to recognize these pretty quickly. So I need the cube root of 8x to the third, which happens to be 2x. And I need the cube root of 125, which happens to be 5. Because 5 times 5 is 25, times 5 is 125. So if I follow the formula we have up here, we're going to use this one right here, because it's the sum. So it tells us we need to take a plus b. Okay, I'm just going to write it down again so you can see it on the screen. It's going to be a plus b, parentheses, a squared minus ab plus b squared. So I'm going to plug this in. So a is 2x, so I have 2x plus b is 5. Then I'm going to take the a squared, so 2x quantity squared minus 2 times 2x, or minus a times b, excuse me, minus 2x times 5, plus b squared, which is 5 squared. Okay, so if I evaluate that, skip over the green, I get 2x plus 5. 2x quantity squared is 4x squared. 5 times 2 is 10, minus 10x plus 25. At this point in time, you might say, oh, look, I'm done. No, you're not done. Because this is now a linear factor and a quadratic factor. Linear because it's only x to the first power, quadratic because it's x to the second power. So 2x plus 5 equals 0, so x will equal negative 5 halves. Okay, so there's one answer. But 4x squared minus 10x plus 25 doesn't factor again unless you put it in the quadratic formula, which we will do. So we'll take that 4x squared, so our a term is okay, so now we'll take this 4x squared minus 10x plus 25. Our a term here is 4, b is negative 10, and c is 5, and 25. Okay, so now we'll put this in the quadratic formula, so we get negative 10, so we get 10, plus or minus the square root of negative 10 quantity squared, b squared minus 4 times a, b squared minus 4 times a times c, all divided by 2a. So again, plus or minus the square root of 100 minus 25 times 4 is 100 times 4 is 400. Okay, so it's 400 all over 8, which will be 10 plus or minus the square root of negative 300 all over 8. All right, so then to simplify the square root of 300, that becomes, right, 300, negative 300, that's 3 times 100. 100 is 10 times 10. Right, so that's going to be 10 plus or minus 10I square roots of 3 all over 8. But as we can clearly see here, 10, 10, and 8 are all divisible by 2. So now we have 5 plus or minus 5I square roots of 3 all over 4. So our solutions to this problem, believe it or not, yeah, that's way, way up there, is negative 5 halves and 5 plus or minus 5I squared to 3 all over 4. So we put the negative 5 halves here. So there's our solutions for what x is equal to. So x is equal to negative 5 halves and 5 plus or minus 5I squared to 3 all over 4. And yeah, that was a rather lengthy problem, I understand, but it was an important one. Okay, let's go to our last problem here. Okay, and I'm going to actually erase some things to make myself have some space. So, erase some stuff over here because you should have already had it, and if not, pause that and go back up on the screen to get it so that I can actually have some space to do my next problem. Okay, my next problem here says x cubed equals 8x minus 2x squared. So let's move everything to one side. So we're going to have x cubed plus 2x squared minus 8x equals 0. Look for greatest common factor, which happens to be x. So now I have x squared plus 2x minus 8 equals 0. Let's see if this will factor. I need a product of negative 8 and a sum of 2. That would be 4 and negative 2. Okay, product of negative 8, sum of 2. That's 4 and negative 2. So I'm going to have x plus 4, x minus 2. So x can equal 0, negative 4, and positive 2. That one was nice because it was easy to solve. Some of them are easier, some of them are more difficult, as you can clearly see. All right. While factoring is an effective way to solve a polynomial equation, you can also find the real roots quickly by using the graphing calculator. You're probably going, hallelujah, okay, because I know I do that. There's two ways to find the real roots by graphing. Okay? I'm not a real big fan of method number 1, but sometimes it's the only method you can use, so I will introduce it to you. Method 1 says graph each side of the equation separately. One is equation as one equation as one, and the other one is the other. Okay? And then use the graphing calculator feature and the intersect feature to figure it out. So if we were going to graph the following equation, okay, oops, and I left my equation off. My equation that we want to graph here should be x cubed plus 3x squared equals x plus 3. So essentially what you're doing is you have two equations, okay? And this is an 84 screen that they screenshot, so this would be an 84 screenshot, but inspired as the same thing. So basically you're going to have an equation, so you can have f of x or y is equal to x cubed plus 3x squared as one equation, and then you're going to put the second equation right in after it is equal to x plus 3. Okay? And then you're going to get both of these graphs, and they're going to intersect. Okay? And you're going to want to say, ooh, what are these points of intersection? I see it intersects here, and I see it intersects here, and I see it intersects here, and I want to know what those are. So you can, doesn't matter whether you've got the Inspire or the 84, you use the same feature. You're just going to ask for the intersection. Right? So you would go to your calculator, and you would, when you're analyzing your graph, you would simply just tell it you want the intersection. Okay? So if I had a graph here on my Inspire, and f of x is x cubed, x to the third power, plus 3x squared. That's one graph. And then, of course, if you graph two graphs on the same thing, remember hit Control G, it brings up your graphing screen again, and I can just put x plus 3 in here. And so I get the 2 points, and the Inspire does it in color, which is really nice. So I have my 2 graphs, and then I just need to go Menu, Analyze Graph, and it's going to give you all kinds of different things. And number 4 is intersection, and you're just going to ask for the intersection. And of course, you're going to scroll it just like you did before. You're going to get a left bound and a lower bound and a upper bound, the left side and the right side, and it'll just tell you where the solution is. And once you do that, you'll see that you have solutions are -3, -1, and 1. Okay. The second method is the method I actually prefer a lot better, because sometimes with this first method, you might miss a point or two because your graph gets off your screen somehow. So I kind of prefer method 2, which is you simply just put the equation into your calculator, because what we remember, our equations are, we had 2 equations. We had x cubed, and we started with x cubed plus 3x squared equals x plus 3, right? So all we have to do is move everything to the left side of the equation, and you get this equation, x cubed plus 3x squared minus x minus 3, graph that, and find the zeros, which will be the same exact thing that you just found, which are -3, 1. So graphing makes it somewhat simpler. Okay, we're going to graph to solve x cubed minus 19x equals -2x squared plus 20. So the first thing I'm going to do, move everything to the left side. So I have x cubed plus 2x squared minus 19x minus 20, because I always like it in descending order of the variable. Then I'm going to put this in my calculator. So I will just get a new graph if I want. Okay. And I will just stick this lovely graph in my calculator, which would be x to the 3rd power plus 2x to the 2nd power minus 19x minus 20. Make sure that in right. Yes, I do. Graph that. So if I graph that on my calculator, I'm going to need to, hang on a second, I have a slight problem. If I put in something incorrect, of course, it gives me a really weird looking graph. Graph this. I can see it looks like it crosses the x-axis in 3 spots. My graph kind of, on my page, my graph kind of looks like this. On my window, it kind of looks like this, and then this, and then this. So I'm assuming it's going to go like this, and then this. Okay, I'm assuming my graph kind of looks like something like that, with the intersections being at these points right here. I can zoom in and zoom out if I want to, but I really only need to know where it crosses the x-axis, so I have everything in front of me that I need. So now I'm just going to put in Menu, Analyze Graph, and I'm going to ask for the zeros. Okay? And so I'll scroll over to the left. I'm going to find my far one to the left first. And I find that there's a 0 there at -5. All right? So I have an x at -5. My next 0, if I find that, remember you're just going to go to Menu, Analyze Graph again. I'm just going to do this 3 times for every place where it looks like it's intersecting. And you're going to find the second one is at -1. And the last one, I do the last one, I'm going to scroll over to the right, and that intersection. And that intersection is at 4. Okay? So I look like I have -5, -1, and 4 is my 3 zeros of this particular graph. Last but not least, modeling a problem. Okay? What are 3 consecutive integers whose product is 480 more than their sum? So basically, the product of 3 consecutive integers equals the sum of the integers plus 480. That's what we're looking for. So first thing we need to do is we need to make sure we define some variables. So I'm going to let x equal my first integer. Since these are consecutive, I don't have to worry about odd or even, so x plus 1 is my second, and x plus 2 is my third. So product means multiply them together, which means essentially x times x plus 1 times x plus 2 has to equal the sum of them, x plus 1 plus x plus 2 plus 480. So the product of those three consecutive integers has to equal the sum of those three consecutive integers increased by 480. So now I'm going to multiply all these integers together. Okay? And so this is going to be x squared plus x. I'm going to multiply that by x plus 2. And this is going to be 3x plus 482. I wrote 83. 483, right? Nope. Yeah, 483. That's 2 plus 1 plus 480, 483. Okay. So now I will continue to multiply. Right? So if I multiply the x squared plus x times the x plus 2, that gives me x cubed plus 2x squared plus x squared plus 2x equals 3x plus 483. So then if I simplify this, I get x to the third plus 3x squared plus 2x equals 3x plus 483. Okay, so now I'm going to move everything to the left side so I can set it equal to 0. So I'm going to subtract 3x. And I'm going to subtract 483. So these will cancel out, and that will give me x to the third plus 3x squared minus x minus 483 equals 0. Now, I need to graph this because that's going to be the easiest way to solve this. So I'm going to stick this in my calculator and I'm going to graph it. So let's put this in the graphing calculator here. X to the third power plus 3x squared minus x minus 483. Graph that. If you look at it, it looks like it's a linear graph, even though it's not. But if I look at this graph right now, it's obvious to me. I can even count it off my screen that it looks like there's a 0 at 7. Okay? So the graph shows that there's a 0 at 7. So if that's the case, then x equals 7. That means x plus 1 equals 8, and x plus 2 equals 9. So my three integers are 7, 8, and 9. And there you have it, solving polynomial equations.